Workshop 1. Measuring the color of wool loose fibers. Why fiber color measurement matters. Welcome to this workshop on measuring the color of wool and cotton fibers. Fiber color plays a key role in product quality, dye uptake, and overall market value. Without accurate measurement, manufacturers risk inconsistent dyeing, quality issues, and costly returns. Today, we'll explore how to assess fiber color effectively using trusted tools and techniques. Understanding wool processing before measurement. Before diving into color measurement, it's helpful to understand how wool is processed. Merino wool is a renewable, natural performance fiber. Each year, Merino sheep grow a fresh fleece, which is then harvested, cleaned, and processed. Wool undergoes scouring to remove dirt and lanolin. After drying, the wool is carded to open the fibers. Depending on fiber length, it either follows the worsted route for smooth yarns or the woolen route for bulkier yarns. The worsted process involves gilling and combing to align and purify the fibers before spinning. Yarns are then knitted or woven into fabrics. Dyeing can occur at various stages, including loose wool, yarn, fabric, or finished garments. Why color measurement is essential. Color measurement ensures that the fiber is clean, grease-free, and meets grading standards. Discoloration can result from environmental exposure, microbial activity, or storage issues. It can also affect how evenly the material accepts dye. By measuring color accurately, manufacturers can control quality, detect issues early, and make informed processing decisions. Consistent color data supports uniformity across batches and production sites. How to measure fiber color accurately. To measure wool or cotton fiber color accurately, color spectrophotometers like the HunterLab ColorFlex L2 is used. This device delivers fast, objective results with Essentials L2, industry's most advanced color analysis software. Here's a quick demo of measuring the color of wool with ColorFlex L2. 1. Place the wool or cotton sample in a sample cup. 2. Use a compression cell set to compress the cotton into the sample cup and eliminate uneven surfaces. 3. Position the cup in the instrument and initiate measurement. Get immediate values for whiteness index, yellowness index, tint, RDAB, CIELAB color space. These indices help assess cleanliness, brightness, and discoloration sources. Types of wool color and grading systems. Wool color is evaluated in 3 stages: greasy, before cleaning; clean, after scouring; and base, post-processing. Poor base color can limit dyeing flexibility and indicate contamination or microbial damage. Global grading systems include those from the Australian Wool Corporation, the New Zealand National Council of Wool Interests, and the International Wool Textile Organization. Selecting the right system depends on your market and customer needs. Common causes of wool discoloration. Discoloration in wool often results from rainfall or humidity, fungal growth, poor storage conditions, seasonal shearing variations. Recognizing these causes helps manufacturers apply effective cleaning and processing strategies. Best practices for reliable color data. To maintain accuracy and consistency in fiber color measurement, calibrate your instrument regularly. Standardize your instrument before each day of operation. Use a compression cell set for uniform sample presentation. Follow standardized cleaning and scouring procedures. Apply the grading system that aligns with your market. Make color your competitive advantage. Measuring fiber color is more than a lab task. It is a quality control tool that protects your product, reduces rework, and enhances customer satisfaction. By integrating accurate color measurement into your production workflow, you create a reliable, efficient, and market-ready fiber supply chain. Let's make fiber color your foundation for success.